Hey guys, today we're going to be going through let me turn the light on actually. Today we're going to be going through one of the problems from this year's British Informatics Olympiad. This problem is keep watching the skies. As usual, the problem statement will be in the description, but I'm just going to walk you through it on a tablet, on a whiteboard. So in this problem, we have a grid. And there is a pigeon, as seems to be fairly common in British Informatics Olympiad problems. We have a pigeon that starts in some cell of the grid, and makes moves around the grid, like in some pattern, to neighboring cells, something like this, and ends up somewhere else. And we are told the number of times it crosses between each pair of adjacent rows, like this, and each pair of adjacent each pair of adjacent columns, like this, and each pair of adjacent rows. So we're given a number for each of these crosses. So in this case, this number would be 0 because it never crossed this line. This number would be 2 because it crossed it and then crossed it back. This number would be 1, 2, 3, and so on. This number is 1, this number is 1, this number is 0. And then same for the columns. So 0, 0. This one we crossed and then crossed back. 3, 2, wait, not 3, this is 4. 2, 2. Okay, so this is what we're given as input. We're given the starting coordinate of the pigeon and these two lists of numbers, and we want to find the final coordinate, the ending coordinates of the pigeon. And so how do you do this? The observation here is that from each of these numbers, all we really want to know is, did it end up on the other side of this line or not? And we can figure that out from the parity of this number. If any of these numbers is even, what does that mean? That means anytime the pigeon crossed that boundary, it ended up crossing back, right? So if a number is even, it means the pigeon ended up on the same side of that dividing line as it started. And if it's odd, like in this case for this 3, that means, why is this 3? It's because it crossed, then it crossed back, and then it crossed back again. So the fact that it's odd means that it ended up on the other side of this dividing line compared to where it started. And that's actually enough to solve the problem. Because if you can now solve the problem actually separately for each coordinate. So you can first let's do the columns. I mean the rows. So what row we ended up in. So we started in this row, and we know that the number of times we crossed the dividing line above is even. So that means every time we crossed back. So we didn't end up above where we started, but the number on the dividing line below is odd, which means we ended up below where we started. So we can step down and check the same thing for the next one. The next one's also odd, which means we ended up below even this dividing line, and so is the next one. And then the next one after that is even. So that means we didn't. Anytime we crossed this, we crossed back. And so we ended up in this row. I mean, actually, this here is 0, so we didn't ever cross that. But if this was, say, 10, this could have also been 10. And in that case, we still know that any anytime we cross this line, we crossed it back. So that's what we do. We start, we know that we started in this row, and then we just, if there's an odd number in any direction, then we just move in that direction. There can't be an odd number in both directions. That wouldn't constitute valid input. But if there is in one direction, then we move in that direction until either we reach the last cell of the grid, or there are just no more, or the next number isn't odd, and then we just stop there. So this is where we stop. And then we do the same thing for columns. So in this case, actually, both sides are even, so we don't do any movement. We don't move, and that's correct. We ended up in the same column that we started in. And so that's how you solve this problem. The code is very simple. It's in the description. And yeah, this was one of the, well, this was the easiest problem in the contest based on number of solves. Yeah, that's the solution. I challenge you, if you're interested, to try and also solve this as a small challenge with constant memory. So using as little memory as you can. So this solution that I described here is linear time, where n is the dimension of this vector. So the grid is n squared in size, but the solution is linear, and linear in space as well, at least the way you would imagine implementing this. But so I challenge you to, if you're interested, as a fun challenge, try and do it with a constant amount of space, just like a few variables. And that's it. That's it. One more thing, you might need fast I/O in this solution because the input size is a bit big. You can check my code for that. That's just to optimize the speed of input-output. Well, just input mainly. There's just a lot of numbers in the input. So that was Keep Watching the Skies. If you want to see the solutions to the other problems from this contest, just check the description, and there'll be a link to a playlist. Goodbye.